Hello, in this video we are talking about section 7.4 on arc length, which is the same thing as the length of a curve. We have discussed the formula for arc length in this lecture already, and it essentially comes from the Pythagorean theorem and finding the length of the hypotenuse of a triangle. So our formula looks like the integral from a to b of the square root of 1 plus our derivative dy dx squared dx. This is if our function is written in terms of x, or we can have a similar formula, the integral from c to d of the square root of 1 plus dx dy squared dy. So this means you have x as a function of y, which you're going to differentiate. This means you have y as a function of x, which you're going to differentiate. Now, sometimes you can choose to use either variable that you want, whichever one is easier, but you have to remember that your function f, and this is either the f of y or the f of x, must be continuously differentiable. That means that f is continuous and f prime is continuous on whatever your interval is, from c to d or a to b. So that's the first thing you need to check, okay? You figure out if f is continuous and f prime is continuous. If it is, then you can proceed with whatever variable you want. If it's not, then you have to rewrite everything in terms of the other variable. So let's see what we have in this case. We have y is equal to x to the 2/3. So I'm going to differentiate first to get that y prime is equal to 2/3 x to the negative 1/3. And we're talking about the interval from 0 to 8. So this function, y equaling x to the 2/3, is definitely continuous. There's no issues there. We can plug in positive or negative values because 1/3 is an odd root, but we can definitely plug in 0 to 8 there. However, for y prime, notice that we have 2/3 times the cube root of x. So this means that x cannot equal 0. So we have an issue with y prime. Okay, so because of that then, y prime is not continuous at x equals 0, which means we must rewrite in terms of y. So we have y equals x to the 2/3. This is going to give us x equaling y to the 3/2. If you raise both sides to the 3/2 power, you will get that power to cancel out there. So we get x equals y to the 3/2. Then to find new values, when x equals 0, y is going to be 0 to the 2/3 or just 0. And when x is equal to 8, y will be 8 to the 2/3. Easiest way to do this is to think of it as 8 to the 1/3 and then squared. The cube root of 8 is 2. 2 squared is 4. Okay, so now we have x equaling y to the 3/2. So x prime will be 3/2 y to the 1/2. And this is defined for all y bigger than or equal to 0. We're talking about a square root function now. It's defined and continuous, really. So we're definitely fine for x values between 0 and 4. So then we can proceed with our length formula. It's going to be the integral from 0 to 4. Notice with these applications, you will always integrate from smaller values to larger values, okay? If you do a u substitution somewhere, then you need to make sure that you're consistent with your bounds. But here, with the applications with length and volume and area, you will always set up your integral so you're integrating from smaller value to a larger value, because you want to make sure that you get a positive length or a positive volume or a positive area. So, integral from 0 to 4 of the square root of 1 plus our derivative, which is 3 halves, sorry, I was looking at the wrong part of my solution for a second, 3 halves y to the 1/2 all squared dy, and we need to integrate this. So let's first off simplify and then see if we can figure out how to integrate. So 3 halves y to the 1/2 all squared is going to give us a 9/4 y dy. And then if you think about integrating this, we have a square root, so it might make you think about using a trig substitution. But we don't have this term being squared. Yes, we could go back here where it's squared, but y to the 1/2 isn't very nice. We could potentially do it with a u substitution and then a trig sub, but that seems pretty complicated. It's always good to start with see if the simplest integration technique works, and that is a u substitution. So if we were going to do a u sub here, probably the best thing to do would be to use what's underneath the square root, because notice that can be written like it's something inside of parentheses. So let's try u being 1 plus 9/4 y. Then du is going to be 9/4 dy, and we can definitely move around that constant and make it work. So this u substitution will work. Let's find new bounds. If y is equal to 0, this is going to give u equaling 1 plus 9/4 times 0, or 1. If y is equal to 4, then u is going to be 1 plus 9/4 times 4, so that's going to give us a 10. So that means that we have the integral from 1 to 10 of the square root of u, then we'll have a 4/9 du. So then we can write the u to the the square root of u as a u to the 1/2 to make it a little bit easier to integrate, so that we get, we'll have a 4/9, then we will have 2u to the 1/2 from integrating u, sorry, that is definitely not right. 2/3 u to the 3/2. My brain just blanked for a second there. All of that evaluated from, at 1 and 10. So we will get, let's see, 8/27, 10 to the 3/2 minus 8/27, or some version of that. You could potentially have the 8/27 factored out, so then you'd have 10 to the 3/2 minus 1. You could simplify 10 to the 3/2 if you want, but remember, I don't require simplification. This is an application, so if you have a proper unit, you need to write it out here. We don't have units specifically, or specific units written, but you can always just write units there. For your answer, it is just units. They're not squared or cubed or anything, because we're just talking about length, which is a distance. So our final answer then, don't care about simplification, so we can write our final answer here as 8/27, 10 to the 3/2 minus 8/27.